Hello everyone, my name is Yang. I'm a PhD student from Institute of Software Chinese Academy of Science. My presentation is effective seed-guided topic labeling for forDataless hierarchical short text classification. With the rapid development of social media, short texts are increasing and widespread on the internet. In this social media, like Twitter, Facebook, people obtain and exchange information through tweets, reviews, and queries. It is crucial to acquire important and interesting information from this huge number of short texts with text classification. And in many scenarios, the category label of short texts are often organized in a hierarchical structure. For example, the products on Amazon or news on the website can be searched through a hierarchy. If we want to buy a printer, first we click Compute and Accessories and then click Printers to get the detail of different kinds of printers. Also, if we want to know the latest news about football, we can click Sports and then click Football. But how to classify short text into a given hierarchy on social media is still a problem. For supervised manner, labeling documents is very expensive and time-consuming for domain experts, so labeled data are hard to obtain. For unsupervised manner, clustering document is less accurate and difficult to acquire interesting content. Thus, many researchers deal with this task with dataless manner or called weakly supervised manner. Only a category hierarchical structure and few seed words for each category are available. However, these seed-guided dataless hierarchical text classification methods are designed for long texts without considering the characters of short text. The short text is extremely sparse and only limited features are available to train and classify. The text of documents on the internet are irregular, so keyword-based methods do not work, and then evolve rapidly, so public knowledge bases are not always suitable. In this paper, we propose a model HireSeed BTM to solve the task of dataless hierarchical short text classification with seed words. By combining word occurrence information and category word semantic similarity based on word embeddings. To effectively utilize the hierarchical structure, a novel iterative propagation mechanism is put forward during the topic sampling process of the topic model. Topic distribution and topic word distribution are propagated in a top-to-down manner respectively in each sampling iteration. Informative experiments are conducted on two hierarchical short text datasets to show that our model outperforms the state-of-the-art baseline methods designed for long texts, especially when the documents are very short. Our model consists of two steps. The first is to estimate the category pi's word similarity matrix, which provides prior knowledge about the relation between the topics and batemas. The second is to infer document topic distributions in each level, incorporating the information above into the generative process of a batema-based topic model to adjust and optimize topic word distributions. Next, I will introduce two steps in detail. In first step, we assume that word similarity scores based on word embeddings can we present the semantic correlations between words. For a category seed word and a corpus word, we get the word vectors through the word embeddings and then calculate the word similarity of these two words. Then we compute the category word similarity dirt as the maximal similarity between each seed word and the document word. Next, we calculate the category bytemark similarity for each bytemark. Theta B equals the mean view of dirt W1 and dirt W2. To leverage the hierarchical and structural information, the path from root to the leaf node C is denoted as a P. Our model propagates those semantic similarity along P to obtain the category path bytemark similarity, where U is denoted as the upper category of category K in level I of path P, and the ZP is the sum similarity of path P from category C1 to CH. Obviously, the semantic similarity P can be utilized as bytemark category distribution directly to calculate the document label, but the similarity only contains the external word embedding information without considering the co-occurrence information or the corpus. We propose a generative model to modify the semantic similarity based on BTM, named Hierarchical BTM, which leverages the prior similarity information and hierarchical structure information to guide the topic labeling. In Hierarchical BTM, the generative process of a topic Z is influenced by both prior category path bytemark similarity P and the topic word distribution Z, which guides the model to induce category-aware topics. Moreover, in order to leverage hierarchical and structural information, the topic distribution zeta and the topic word distribution phi are propagated along the path as prior parameters to influence the generative process of lower level. This is a detail of the generative process. First, the thread in level h-1 is propagated to level h, as the category number of level h is different from the category number of level h-1. We assign the topic probability set in level h-1 to the prior topic probability in level h along all paths in the hierarchy. Second, draw a topic word distribution set h through Dirichlet distribution. Third, for each topic K in level H, draw a topic word distribution phi H through Dirichlet distribution. Fourth, for each bytemark B in bytemark set, modify the topic distribution set B with zeta PB and zeta. Draw a topic Z through multimodal distribution. And finally, draw two words Wi and Wj through multimodal distribution to form bytemark B. As the model is intractable, we utilize the deep sampling to prove for the approximate inference. After random initialization on the Markov chain, we iteratively calculate the conditional distribution for each bytemark in each level. With the sample results, the topic distribution state h and the topic word distribution phi h can be calculated as this equation shows. This is the whole deep sampling process of our model. For each iteration, we iteratively sampling all bytemarks in each level and update the set and phi to low level. The classification result or model are obtained from the leaf level, and the probabilities on linear categories are calculated by summing up the probabilities of the shared categories. Especially, we treat the expansions of topic propagations of bytemarks in documents as the topic proportions of the top document. For document D, the category label Z can be predicted as a topic with the highest probability, as the equations show. In the section experiment, we used two hierarchical short text datasets to evaluate the effectiveness of a model. For both datasets, we at first lower and lematize all corpus words and remove stop words, and then filter out the documents that contains only one word and more than 50 words to obtain the short text datasets. The 20 news groups is a widely used dataset for the text classification task. It contains about 20,000 newsgroups messages from 20 newsgroups. HuffPost is obtained from HuffPost and contains around 200,000 news headlines from 2020 to 2019. There are totally 42 categories, and many of them are overlapping. From these, we select 9 leaf categories with 3 upper categories. We evaluate our model with 6 baseline models. All of these can leverage seed words to deal with the task of text classification. The first 4 models are dateless or weakly supervised hierarchical text classification models, and the last 2 models are dateless short text classification models. In fact, here seed BTM is extended by seed BTM to deal with the task of dateless hierarchical text classification. This page shows the experiments of our model and the baseline models in 2 datasets. The best results in the table are highlighted in bold, and we can observe that here seed BTM performs better than almost all baseline models in 2 datasets. For WSH class, the pseudo-label documents are relatively noisy and the trend classifier cannot well distinguish short text due to the sparsity feature. So WSH class gets poorer performance in HuffPost than the generative models. For PCEM, only category word similarity and propagated along passes, but our model further propagates the distribution among each iteration and gets better performance. The result indicates that the propagation mechanism and generative framework for short text make our model more effective to leverage the hierarchical structure information and alleviate the data sparsity of short text. Moreover, the performance of baseline models fluctuate among datasets with different lengths, while here seed BTM behave more stable. Here seed BTM also get a better performance than seed BTM and its variant model, which explains that our propagation strategy based on the hierarchical structure can integrate more evidence from different abstraction levels to classify short text accurately. We study the impact of iteration number and parameter better. For the iteration number, when the number of iterations is 6, here seed BTM can achieve good classification performance, and F1 score is almost stable after this point. Therefore, we set the iteration number to 8 in our model. The fast convergence should give credit to the regulating effort of information propagation mechanism among the hierarchical structure and the prior knowledge from word embedding. For the impact of beta, the flight lines of 20ng dataset indicates that the dataset with a longer text length is relatively insensitive to beta, but for the shorter half-burst, the results fluctuate and achieve at the best performance in range of 0.3 to 0.4. Thus, we set the parameter beta to 0.3. In conclusion, we propose an effective model for dataless hierarchical short text classification. Our model leverages lead words to guide the generative process of BTM for topic labeling and introduce an iterative distribution propagation mechanism to incorporate the hierarchical and structure information. Moreover, the propagation mechanism brings effective performance because of the fast convergence. Experiments on both hierarchical short text datasets show that our model performs better than other baseline methods, especially when the length of the document is extremely short and more space. In the future, we plan to study how to incorporate contextualized vector representation to better track this task. In addition, it is important to study the impact factors of datasets for classification accuracy, such as category, imbalance, and bias as well as different hierarchical structure.